Good morning, children. Today we are going to see the next topic in our lesson, light. Okay, which is the image formed by a plane mirror. In a previous lesson or in the previous video, we were talking about the laws of reflection. First law, the second law, what is the incident ray, what is the reflected ray, and then the two types of reflection, the regular, diffused, etc. Now we are going to discuss how the image is formed by the plane mirror. Okay, we already know a mirror is nothing but which reflects. That means it is a polished body, so it will be reflecting the light rays. Okay, so the image can be formed. So when the mirror reflects the light, an image is formed. That is what I am going to see or describe how we are going to see the image. Okay, now let MM be the mirror. Okay, how are we going to draw the mirror? For a plane mirror, obviously mirror means a plane mirror, we have to draw one line and you have to draw small drawings in the end like this. Okay, small lines. Like when we are drawing our coconut tree leaves, you have to draw, because we are going to say this side, thus the straight line side is the side which is going to be reflecting. This line, the line side, is the one which is not going to be reflecting. Okay, so to say that only, or to draw that only, we are drawing like that. Draw one straight line and put one side lines. Okay. Then now consider the object of height AB. So the AB is the object, and then at a certain distance, so it is moved away from the point O. Okay, O is the center of the mirror. Okay, now AO is the incident ray. AO means this is A, that is the point A, AO. So that means the light is not coming from here, it is going to be coming from somewhere. Okay, so let AO be the incident ray. Okay, the moment it is getting incident on that particular point, it will be reflected. So OY will be the reflected ray. Okay, OY is the reflected ray. Now we know the angle of incidence is equal to angle of reflection. So AO, what? AOB should be equal to AOB. Where is B? This B. AOB, this angle should be equal to this angle. These two angles should be equal. Okay, so that AOB is equal to angle BOY. Okay, now consider another ray AC. Another ray AC. Okay, what will happen? This AC is going straight. Okay, this ray is incident normal to the plane of mirror. Normal means what? It is going in a perpendicular direction. Perpendicular means the 90 degrees. So it goes straight. So when it goes straight, the angle of incidence is 0. That means angle of reflection also should be 0 according to our second law of reflection. So what happens? The moment it goes and strikes on the plane of the mirror, it has to come back on the same way, because the angle of incidence is equal to 0. The reflection also will be equal to 0. So it will be coming back in the same direction. So only the two arrows are in the opposite directions. So it is reflected along the same path. Okay, so we have considered a mirror MM dash with a midpoint O. Now I am having an object of height AB. Okay, you can take an example for pencil or one small box, or you can take like a small teddy bear or a candle, anything. Now the light ray will pass one. We are not talking about only one ray. There will be many rays, but we will be only considering the first ray, like which is passing through A. It will go strike the point at O, and then it will be coming out. That is the reflected ray. Okay, now this angle AOB will be equal to angle BOY, because that is the law of reflection. Then consider another line or ray which is passing through the point A such that it is normal to the plane of the mirror. Normal, it should be normal. So the angle of incidence is equal to 0. So obviously it will be reflected back along the same path. If it is reflected along the same path, we have 2 points now. We will see how this image is formed. Now we are going to draw the image. How is that drawn? We are going to extend the same diagram they have drawn here. Okay, they are extending it to the next side. Okay, so this ray, OY ray, is extended. Extended means it is being pulled on the other side. Okay, like imagination. So we are going to pull it like this in the straight line, and this the next. This line is also the next ray. So these 2 points will be intersecting at one point. That is the point A dash, and you draw one line from there, perpendicular line, that will be B dash. Okay, though the extended rays will intersect at a point called A dash. So the image is A dash, B dash is the image. Okay, so this is the image. Okay, so the image formed is of the same size. First one is the same size, that is object size is the same as that of the image. Then they are at the same distance, that is OB is equal to OB dashed. Okay, now we are going to do this activity. You can do this activity at your home itself, and you can see what are the things you understand. First is you take a mirror. Okay, now you take a cardboard cutting with a letter L. It can be L or M. Okay, you can first take L. That will be very easy. Okay, now keep the vertical mirror, keep the L. Okay, now look at the image formed by the mirror. How will it be looking? The image is formed on the mirror itself. It will be looking in the opposite direction. Is it not? That is what we are going to observe. First thing, the image formed by the mirror cannot be projected on the screen. It cannot be projected. It is formed on the mirror itself. That means we are going to see the image on the mirror itself. So it is virtual. Okay, first point is virtual image. Then the image letter is reversed. That is left and right are interchanged, so reversed. Then the image is erect. Erect means it is always straight. It is not slanting or disturbed. Okay, and the size is same. Okay, so this is all we are going to found. We have found out these observations: virtual, upright, same size, and reversed. All these 4 things are being concluded with this simple activity. Coming to the second activity is, we'll see this activity first, and then we go to what is this lateral inversion. Take the mirror, okay, meter scale and a pencil. Okay, now place a plane mirror on the table, then take one scale, keep one scale out distance, then hold the pencil. Okay, now and move it towards the plane mirror. Compare the size of the pencil when the size of the image of the pencil that appears on the plane mirror. Next, now first observation, we have kept at 1 meter distance. Okay, that is of 1 meter scale. So a pencil and the image are of the same size. Okay, now when I am going to move the pencil towards the mirror, okay, then it will be bigger. The image of the object, the object and the image are at equal distance. First point. Then the image is of the same size as that of the object. Okay, so you need not do the second observation. You just find only the first observation. That is enough. Okay, so with that input, we are going to see what is this lateral inversion. Inversion means what? Okay, inversion means it is going to be ulta. Okay, so this is what we are saying. This is for right left. Lateral means right and left. That is what happened when we always see ourselves on the mirror. Is it not? If you want to touch your right eye, you will be touching your right eye. But on the mirror, it will be shown as you are touching the left eye. So that is the lateral inversion. So the phenomenon in which the object appears to have a left-right inversion is called lateral inversion. So this is the important thing. Okay, that is why the word ambulance is written. Okay, ambulance is written in the laterally inverted way, because when we are driving, there will be a mirror in the driver's seat, is it not? This mirror, center mirror, this mirror will be always showing in the lateral inversion. So if this ambulance is coming, if we don't see the spelling, or we don't see the light here, we will be having a confusion, because there will be always a left right inversion. So while printing this word ambulance on this vehicle itself, they will do the lateral inversion and print it like this. So for our vision, when we see it through this mirror, it will be properly written as ambulance. The moment you read the word ambulance, you will leave the way for the ambulance to go. Okay, otherwise when you without looking into the mirror, if you just look at the this word, it will be laterally inverted. You cannot immediately make out what the word is, unless and until you can make it out from the symbol, the plus symbol, or the siren sound, or the siren light. Otherwise you cannot make it out. Okay, so this is the example for lateral inversion. Now we will see what are the characteristics of the image formed by a plane mirror. First characteristic is virtual. Virtual means we cannot project it on the screen, or we cannot take it outside. It will be there itself. Okay, and erect. Okay, then erect means it is always straight. Then there is a lateral inversion. Then the size is the same as that of the object, and the distance is also same. Okay, now with that we are going to follow the multiple reflections. Multiple reflections means what? You have gone to a beauty parlor or a barber shop. There you will be having lot of mirrors lined all together, right? All will be there. Okay, if you sit at one place, the moment you sit in one place, your reflection will be seen through all the mirrors. Okay, so where this is the place this multiple reflection is going to happen, because there are multiple mirrors. The multiple mirrors, so this multiple reflection will happen. When two or more mirrors are used, light undergoes reflections many times, because there are different mirrors and we can see many images. So this phenomenon is called multiple reflections of light. Okay, this we can see even in our example as kaleidoscope, which we will see in the activity. You can do all, make one kaleidoscope also for activity. Okay, if we place two plane mirrors parallel to each other, we can see infinite number of images. When they are parallel, you will see infinite number of images. Okay, then the number of images depends on the angle between the mirrors. So the angle between the mirrors will decide the number of images. Okay, we have this example here. We can take two mirrors. Okay, two plane mirrors, a protractor and a white sheet. Okay, now place draw lines for 30 degree, 45 degree, 60 degree and 75 degree on a white sheet with a protractor. We already know, we have done this in our 6th standard, how to draw angles using this protractor. Arrange the mirrors such that angle between them is 30. That is, if the angle is at 30, place one mirror here and place another mirror here. Okay, observe the number of images. Then keep the mirrors. Now how will you find the images? You should place an object between the mirrors. Okay, here in the materials required, we write object also. Okay, then change the angle. Put the mirrors at 45 degree. That also will change the number of images. So the number of images is dependent on the angle between them. So what is that? Capital N is equal to 360 by alpha minus 1, where alpha is the angle between the two mirrors. You should know this formula, very very important. Okay, so this multiple reflection is the one is where we use for optical devices like periscope, kaleidoscope. Okay, periscope, it will be in a tube, right? It is used to see the object situated at a higher level. You keep your eyesight here, you can see the object at a higher level. Kaleidoscope is used to see colorful patterns. Okay, so you will be placing 2 mirrors, 3 mirrors, then you can put small beads, colorful beads inside that, then you can have many patterns formed from the kaleidoscope. So your activity will be activity term 2 activity. You should make a kaleidoscope. You should make a kaleidoscope. Okay, you should make a kaleidoscope. You can take the input from YouTube. You can see many videos how they are making the kaleidoscope, and you can make one. Okay, then this revision zone you should do it as a homework. Okay children, this is your homework. Okay, thank you.